everyone, in this video I'm going to explain to you step by step how the code for our science scraper agent for the quantifying ovarian aging project works. So first of all, this here is the GitHub page. Here you have the README, which goes through everything as well as I will go through now. Here's actually a very nice graphic. Don't think you can see it so well because I'm in a dark mode, but let's go through the files. You can see you have a gitignore file, like all the obvious stuff. It didn't refresh. Haha. Here's the new version. So all the magic happens in the src directory, the source directory. You can click into that, and here you can see the code. In the source/agent directory, in the prompt directory, we just store some prompts. In the agent directory, this is where the magic happens. Here's all the code. The main function, like the main file, is the agent.py file. In this file, we use LangGraph to iteratively do multiple steps. So in the first function, like first of all, we define state, which is typical for LangGraph. Then we ask the agent kind of to create a query. Like we start this by giving the agent a health outcome that we're interested in and how this health outcome is influenced by early or late menopause. So first we start with this query. So the agent starts creating a query. After creating this query, this is the prompt for creating a query. This query is put into PubMed, and there's a search function of like the query is searched for in PubMed. So we get a lot of metadata and abstracts for papers. Then there's a filtering step in which we remove all the papers that we previously got, because the agent doesn't only create a query once, it creates a query multiple times, and we don't want it to go over the same papers again and again and again. So here we just filter out all the papers that we already looked at before. In the beginning this is no papers, but later, the longer you run it, the more papers are on the kind of blacklist for the filter. Next step, we have the agent check the abstract. So the agent looks at every single abstract like separately and is asked to classify if that abstract is relevant to our, let's see it here, our disease of interest. And then the agent says either yes or no, and depending on what he answers, the abstract is passed on. If he says no, the abstract is just like discarded because it's not relevant to our question. If he says yes, we keep going. In the next step, we download the paper, and that is actually like for me, like for the coding part, this was one of the hardest steps, because all the publishers try really, really hard to prevent people from programmatically downloading papers, even the open access ones. So closed access ones, you don't have any chance. You need to have, like, either you use Anna's archive or you have to go through your university subscription. So this only works for open access papers, but even open access papers have super strong bot detection. So what we use here is another module, another file, which is the DOI to PDF file. I'm really proud of that one, which then uses Bright Data, which is a web unblocker, to access the paper. So yeah, here's like all the logic how the paper is downloaded. I'm not going to go in detail through that, but if you're interested, I made a nice docstring string to explain how the paper how this file works. But going back to the agent, so let's say it succeeded in downloading the paper. In the next step, it extracts the metadata from the paper. So it gets the whole text of the paper, which is turned into Markdown. Also quite a complicated process. I'm doing that in which one? DOI to PDF? No, PDF to Markdown. In that one, I wrote the code for how to turn PDF into Markdown. It's actually using two different libraries, and just one is balancing the weaknesses of the other. So it's not too complicated, but a bit. Then we look at the paper and we extract some metadata. So right now we're just looking at meta-analysis. So it's looking at the number of included studies, the sample size, the geography and confounding variables, and is returning that. In the next step, we evaluate the study based on robust criteria. Robust criteria are just it's a scientific way to judge the quality of meta-analysis or like scientific papers. So the robust analysis goes, it's again an agent that reads through the papers and walks through this robust analysis and ends up giving two scores. This is the robust categorical risk score and the quality score. In the next step, the final step, kind of, we extract the risk matrix. So this is where the real important stuff is extracted. So here the agent goes through, reads through the paper again and extracts all the risk metrics. So we extract the menopause timing definition, the health outcome, the metric type, the metric value, and the confidence interval. Down here, there's this function, tracked file downloads, is just for closed access papers. So those files are just stored in an extra CSV file for later processing, so you can download them yourself through your university and then put them again into this pipeline through another file, which is called paywall.pdf ingester. So you don't lose any paywall PDFs, which we were really struggling with in the beginning. Here, after this, is just the routing logic. It's not so relevant for you. This is just details of how to plug everything together, and that is it. Down here, you can see how to run the function. This is the basic way to run the agent. You go agent.invoke, and you can specify some extra stuff. For example, the maximum number of metrics you want to extract. So here it would stop after extracting 10. The maximum number of papers you want to look at, so it would stop after 30. The max number of queries you want to run, so it would stop after 30. So if any of those three is reached, it will stop extracting. And if you want to know where our main data is, it's here in the final extracted data CSV. And we worked really hard to prevent hallucination. So I dare you to just open that CSV and go to any DOI. We have all those DOIs here, like 500 something DOIs. Go to any of them and check if the values are accurate, because I'm very confident they are accurate. Put so much effort into that. And lastly, you can go in the white paper folder, and here you see a PDF of our white paper that explains the exact methodology that we use to calculate the final number and everything. Peace.